Can you see the screen?
Yes, sir.
So in the last class, we have completed forging, right? So today we will start from the rolling. So we will talk about today only the basic background. We will talk the rolling introduction, what is basically how we are calling this rolling and what are the basic classification for rolling process. And also few rolling mills we have to talk, variety of rolling mills, what are the traditional rolling mills are available. Then also when we are changing or when we are going towards new technology, how the rolling mills are changed from the when from the traditional rolling mills. So if you go to the, can you just define what is rolling from your knowledge, what you understand from the rolling? I do not see the PPT. Just you can tell. Anyone? You already we have talked about the forging, and in the beginning, if you remember, when we talked about the mechanical working, we have also derived their forging, rolling, extrusion, sheet metal drawing, everything we have covered there. You know the basic funda there.
Well, it is a process where thickness is reduced by uh, putting the workpiece between two rollers.
Yeah. Okay. Okay. Okay, fine. So the rolling is a deformation process. We are talking about the mechanical deformation process here, in which the thickness of the work. So if we see the schematic diagram here, this is just a, the rolling process. I have just taken one schematic diagram here. You have two rolls here. One is in the upper side and one is in the lower side. And whenever you have the two rolls, the metal piece you have, or maybe the whatever the long piece, because we are not thinking about small one, because normally this kind of work you cannot do in a laboratory scale. Difficult. Maybe some lab they have, but accurately, what I told in the forging also, this kind of work you cannot do accurately in laboratory. So you have to go to the company. So you have the thickness, initial thickness here. So you are reducing from the original thickness by a compressive force. So the compressive force you are created within the two rolls here. And the rolls rotate as to pull and simultaneously squeeze the work between them. So there are two things here. The metal piece, whatever you are putting from the raw material side or the initial side, the metal you are pulling by the rolls. Then also at the same time, this metal piece squeezed by the two rolls. Okay, two work you are getting here. And the basic process shown in the figure, it is known as the flat rolling, because you have the flat metal piece here. Then also you are making a flat surface here. You are not preparing any wear or maybe any smaller width here. You are making the same width here, but also the metal piece also you are making in a flat surface. Okay, used to reduce the thickness of a rectangular cross section. Okay, so whatever the cross section, the rectangular cross section we have, in the similar rectangular cross section, you are getting this product. A closely related process is a safe rolling. So apart from that, because sometimes we cannot find in a proper accuracy in this. So if you have a safe rolling, then probably you will find the accurate size there. If you remember in the forging also, we talked about the precision forging. Similarly, here you want to make it safe rolling. So that means the accurate shape you want to find out. Because here, for example, after flat rolling, you will not find the accurate shape. But here in shape rolling, which square cross section is formed into a shape such as an I-beam. So if you want to prepare a, let's say, I-beam or maybe any kind of other T section, for example, you can use the shape rolling process. Most rolling processes are very capital intensive, requires a massive piece of equipment called rolling mills to perform them. So whenever you are talking about this kind of rolling process, these are very expensive because these equipments are very big, and also you can keep in a big area, or maybe the workshop what we are telling. You cannot put the equipment we are putting in our laboratory. Probably you cannot put like this, and if you will put also, you cannot take a big or long billet there or long slab there. Okay, you have to take small pieces. Then that one you have to do, right? And the high investment cost requires the mills to be used for production in large quantities of standard items such as sheet and plates. So you have to, maybe we will just define everything: what is sheet, what is plate, what is billet, what is bloom, what is ingot. We all will define, because everything we know, because every time we are using, this is a sheet, this is a plate, but we do not know how to define that plate and sheet. Most rolling is carried out by hot working, called the hot rolling, because these are also, we know about the hot working, cold working. Can you just tell what is hot working and cold working? Anyone? All forgot. Based on the temperature. You remember? Above the, if hot working, above the hot temperature.
Sir, I think one is about recrystallization
Yeah,
temperature.
above the recrystallization temperature. And if cold working is below the recrystallization temperature. Right? Okay, so the most rolling is carried out by the hot working called the hot rolling, owing to the large amount of deformation is required. Similarly, in hot rolling, you do not have any, generally free of residual stresses because it is at a high temperature. Then your pressing should be in a perfect way. So you will not find any residual stresses there. And what are the basic disadvantages? Because in every process you will find some advantage and also few disadvantages there. And the disadvantage is that the product cannot be held to close tolerance and the surface has a characteristic oxide scale. Okay, so that means when you are talking about the rolling mill or the hot rolling mill, you are finding you cannot find a very close tolerance. For example, like if you want to this kind of shape you want to prepare, you cannot prepare. Maybe it will plus minus. You will not accuracy will get. And second is when you are making at a high temperature on the surface, you will find a oxide film there or oxide scale there on the top because it is at high temperature. So maybe it will be aggressive to the air or to the moisture or to the environment. Right? Is it clear? Yeah. Okay. So now when we are talking about the rolling, so now we have to understand how actually from where actually it is coming. So one example just I have taken in other way, if you know the iron making and steel making. So I have just considered the steel making process here. Steel making means you are producing initially the iron or the pig iron with the help of blast furnace. Then maybe you have covered this one in manufacturing of that casting process. So we are putting the iron ore, dolomite, limestone, coke, everything we are putting in the blast furnace. From that blast furnace, we are taking the pig iron, and that pig iron we are putting again in steel Bessemer or the Bessemer process. So again, we are converting to the steel. Okay, so that we are talking about that steel making when we are using or when you are preparing. So that steel, how we are going to or how we will take that steel to a rolling mill. Okay, so let us follow the sequence of steps in the steel rolling mill to illustrate the variety of product. So similar steps occur, whatever we are doing in the steel making process, the similar step also you can go to whenever you are preparing any liquid metal, for example, in cupola furnace or maybe an induction furnace, you can also follow the similar way. There is nothing a big difference. So the work starts out as a cast steel ingot that is just solidified. So that means whatever the product you are getting from the steel making, so that product is known as the cast steel ingot. Okay, so that means this is just solidified from the liquid. And while it is still hot, so the moment it has at the still hot position, the ingot is placed in a furnace where it remains for many hours. So that product you have to keep in a furnace and you have to keep for longer time until it has reached a uniform temperature floor, because you are not keeping a small piece, you are keeping a very big piece, and that piece you have to put in a furnace so that you have to keep for that time, maybe 2 hours, 3 hours, or maybe 10 hours, but you have to make to uniform temperature everywhere of the sample, so that the metal will flow consistently during rolling. So the moment you are making the rolling, so that will consistently flow. If it is not uniform everywhere, maybe it can stop somewhere because there is a temperature difference. So for steel, the desired temperature for rolling is around, you have to take almost or close to 1200 degrees centigrade. And the heating operation is called soaking. So whatever the ingot you are getting from the steel plant or from the steel making furnace, so that one you are putting in the furnace, and that furnace is known as the soaking process. And the furnace in which it is carried out are called the soaking pits. Right? Is it clear? So the process is known as the operation is known as the soaking, and whatever the soaking you are making in that furnace is known as the soaking pits. Fine? Yeah.
Yes, sir.
Okay. So now from that soaking pit, so now our the mechanic, because that only process I just put in two three lines, because we have to why we are going to that process, because we have to understand what are the the terminology what we will use, for example the blooms, billet, and seal. So from soaking, the ingot is moved to the rolling mill, because this is important, because for that we have to go from where actually it is coming. Otherwise you will again ask, sir, from where it came. So ingot is moved to the rolling mill, whatever the ingot you are getting from the steel plant. So that ingot is going to the rolling mill where it is rolled into one or three intermediate steps. From that you are finding or you are creating, one is bloom, second one is billet, and third one is slab. Because sometimes, like, probably I do not know the bloom. I think you have normally used in common way, but we are, telling every time billet. Then we are also sometimes we are telling these are the slabs. Okay, but we do not know how exactly or what are the parameters and how we will tell that this is. A bloom has a square cross section of 150 into 150 mm. For example, 6 inch to 6 inch or larger. So if this kind of piece you have, then you are telling this is a bloom material or it's a bloom. And a slab is a rolled from an ingot or a bloom and has a rectangular cross section of width 250 mm. Okay, and also more, and thickness is around 40 mm. So if in this size you are getting, so these are known as the slab. And this bloom and slab, both you are taking or both you are getting from the ingot only. Okay, so bloom also you are getting from the ingot. The slab also you are getting from the ingot, as well as also sometimes you are getting from the bloom, right? And the third part we have the billet. A billet is a roll from a bloom. So from the bloom you can derive the billet. A billet is rolled from a bloom and is square with the dimensions of 40 mm. So that is very smaller size, because here you can see this is around 150 mm. Okay, from 150 mm you are getting around the thickness is 40 mm. From again you are getting around 40 mm or maybe a little larger. So the three things you are getting, one is bloom and slab and billet. And bloom and slab, bloom you are getting from the ingot, slab you are getting from the ingot as well as the bloom, and the billet you are getting from the bloom. Okay, so these are the basic definition of the bloom, slab, and billet. What you are getting from the steel plant or any furnace, and that one you are sending to the rolling mill. And the bloom, billet, and slab are known as the semi-finished product. This is not a finished product what you are selling to the market or selling or maybe giving to the other people or maybe the consumer. And these intermediate shapes are subsequently rolled into final product shapes such as plate, seat, rod, bar, pipe, rail, and structural shapes. Okay, so that means all these products, whatever we are preparing here or whatever we are getting, for example, the plate, seat, rod, and bar, these are you are getting from the semi-finished products such as bloom, slab, and billet. Fine. Is it clear? Yeah.
Yes, sir.
Okay.
Yes, sir.
So now, three things I just told. So now again, we have to, I will show some of the schematic diagram, how it looks like. Okay. So the blooms are rolled into the structural shapes. Now you have three things. So one is the bloom, billet, and slab. So again, from, the structural parts or maybe whatever the pipe and bars, whatever I just told in the previous slide, in the last point. So the blooms are rolled into the structural shape and rails for railroad tracks. Okay. So whenever you are preparing the structural shape, these are normally coming from the blooms. Similarly, whenever you are producing some bars and rods, these are you are getting from the billets. And these shapes are the raw material for machining, wire drawing, and forging. Okay, so this kind of material you are going towards the machining. If you remember that machining, what we have talked in the previous semester, this is going to the machining, this is going to the wire drawing, what we will cover in the coming modules, and also this material is going to the forging, what we have already discussed in the previous module. And the slabs are rolled into the plates, sheets, and strips. Okay, these three things also you have to understand what is actually plate, what is sheet, what is strip. Because every time we are also using the same kind of terminology in our daily life. But we do not know how we are telling and what exactly the plates are, what exactly the sheets are, and what exactly the strips are. So the hot roll plates are used in shipbuilding, bridges, boilers, and welded structure. Maybe sometimes you will tell that, sir, whether because we all are mechanical. So whether this kind of work, whether really this is working in mechanical people or this is not working. So you can see here. So the hot roll plates are used in shipbuilding, bridges, boilers, and welded structure. Okay, so now you have to compare these techniques also we are using. So we have to correlate with. We cannot tell that this is only mechanical people they can work. All the people, because this depends upon mechanical. This depends upon electrical, because all the electrical maintenance, the electrical people they will do. Okay, so we cannot tell that only one we will do as a mechanical or maybe the materials people. Okay, and the further flattening of hot roll plates and seats is often accomplished by cold rolling. So after that, the moment you have finished the hot rolling, then also it can go for the cold rolling in order to prepare them for subsequent sheet metal operation. So why we are going for the cold rolling? Can you just tell why the cold rolling is necessary? If you have the hot rolling already you have done, or maybe hot working when you have studied the working, if you have finished the hot working, so why we are going for the cold working? Anyone?
Sir, for better surface finish.
Yeah, yeah. Okay. Any other? Okay, fine. So the cold rolling strengthens the metal. So you have to find the good strength of the metal. Then also the surface finish. Then at the same time, also you will find the close tolerance or the close thickness, whatever. Okay. So what I told in the previous slide also in hot rolling, you are not finding the close tolerance. So that we have to go for the cold rolling. In addition, the surface of the cold roll sheet is absent of scale. So whatever the the film or the scale you are generating in the hot rolling, these are also you have to remove here in cold rolling. Okay, you will not find any layer. Okay. And these characteristics makes cold roll sheets, strips and coils ideal for stamp. So then this material, if you are preparing with the help of cold rolling, then you can go for the sheets or strips or maybe coils or maybe the stamping, whatever I told about in the previous module, we have the coining. Okay, that coining we have prepared, but now you have to go for the stamping. Okay, so that means you have to because this is now your surface finish is there, your tolerance is there, then your strength is there. So you have to go for the stamping. Is it fine? Yeah. Okay. Yeah. So now just I have shown you, whatever I told, you have three kind of form here. So one is the bloom. In the left hand side, you can see this is the bloom piece, and this is the slab piece, and this is the billet. Only this is schematic diagram. Just you have to understand that from where, for example, if you have three initial stages initially or three kind of product you have from bloom, in theoretically also I have explained the previous slide. From the bloom, you are getting to the structural shapes, for example, the rail tracks or something. Then again, from slabs, you are getting or you are going towards the plate and seat and, for example, the coils. And from billet, you are going to the bars and rods. These are the basic, uh, the necessity, but we are getting because this is easier. Probably sometimes you can ask, sir, from slab, is it possible to make structural shapes and rails? I do not think it is because if you want to prepare some structural shapes and rails, you need this kind of thickness. Okay, so if you have this kind of thickness, then only you can do. So if your thickness is very small here and your thickness is larger here, it is required thickness, then you cannot go. So that's the only option is that from the bigger thickness, it is easier to find out or it is easier to do, right? So similarly, the difference between the plate and seat, what I just told now that we have to understand also what is the basic difference between plate, seat, and strip. Okay, so these three things you have to differentiate with the help of us with respect to the thickness of the product. In general, the plate has a thickness greater than 6 mm. Okay, so you have to define. You cannot tell that, sir, that this is plate or this is seat. So you have to understand very clearly. Okay, of course, in the beginning, you have to remember many things, but the moment you will work in a company, every day you will see the same thing, same thing. So you will remember automatically when you will see, you can tell this is a plate or this is a seat. Okay. In general, the plate has a thickness greater than 6 mm, although there are exceptions to this limit. Sometimes you have the error plus minus 1 or maybe plus minus 2. Seat and strip as I refer to roll products which are generally, okay, so this term is generally, then the second term I just define a product. The seat and strip, when we are talking, the thickness is less than actually 6 mm. Okay, so of course the plate you have more than 6 mm. But when we are talking about seat and strip, these are actually less than 6 mm. But if you want to define clearly, the strip refers to the roll product with a width no greater than 600 mm. So that means it will be less than 6 mm. The moment you have the less than 6 mm, then you are telling this is as a strip, right? And the moment the seat refers to the product of greater width, so that means it will be a little greater to that. Okay, but if you will tell very accurately or very closely, then you can tell this is less than 6 mm is known as a seat and strip. Then if it is more than or greater than 6 mm, this will be the plate. But somewhere if you want to define very clearly, again you have to go, again you have to define the seat and strip with more than 600 mm or maybe 6 centimeter or less than 6 centimeter, right? Is it fine? Yeah.
Yes, sir.
So now, when we have understood the different kind of material, what are the initial raw material or initial pieces, whatever we are putting to the rolling mill, and what are the product of what are the different sizes you are getting from the rolling mill. These are all we understood. So now we have to understand that in conventional hot or cold rolling, the main objective is to decrease the thickness of the material, what we have studied in the beginning of the introduction. Okay. Ordinarily, little increase in width occurs so that the decrease in thickness result in an increase in length. Sometimes, like whenever we are making very big piece, we are taking. We are not taking very small piece, like for example, 10 millimeter or 20 millimeter. This is a very long piece, and this is continuously this is going. So you cannot tell that every time, like very exactly the same thing we are taking. Okay, so this is not a laboratory scale. This is a big scale. Maybe plus minus somewhere the tolerance you will find. So the roll forming is a special type of cold rolling in which a strip is progressively bent into complex shapes by passing it through a series of trim rolls. So what we have, I have shown you just one schematic diagram that you have two rolls, and with that two rolls, you can prepare some the metal piece or maybe strips or maybe the the strips, right? But the moment you have roll forming, because you cannot do every time two rolls you have, but all the metal whatever you are getting from the steel plant, you have to roll everything. It is impossible. So in that case, what you have to do, you have to make some series of rolling equipment. So the roll forming is a special type of cold rolling in which a strip is progressively bent into complex. So that means whatever the metal you are getting. So also according to your if you want to make it some bent position or in angular position, also you can make. And the thickness of the metal is not appreciably changed during this process. Roll forming is particularly suited for producing long bolted sections such as irregular set channels and the trim. So this is another technique you have. So if you want to find out some angular section, whatever you are using in the the this construction or the building site or maybe in the workshop, but you are making the angle you are using in the roof, so that you can prepare or you can produce with the help of the rolling. Another specialized use of rolling is thread rolling. With that thread rolling, a plank is fed between the two group die plates to form threads. The thread means small wires, for example, or very small threads you can use with the help of the thread rolling. These are some new techniques are there. Of course, we are not going in detail, but if you want to find out the thread rolling or whatever the new techniques you have, you can just go to that book. You will find in detail. So I'm not going in detail because we have only we have to understand the different kind of classification and different kind of rolling mill. We have to just understand. Okay, that's why I just put. But if you want to go detail, you can just have a look in the book. Fine. Is it clear?
Yes.
So here also one more the new technique whatever we have classified in also the forging the powder forging or forging of the powder. Similarly here also whenever we are talking about the rolling, normally this is coming from the ingot or maybe from some slab or the electroplated slab here. But apart from this, if you want to prepare some density, because here we are getting the density, there is no porosity or something. But the moment we have powders, let's say, from the powders also we can prepare some densities. Okay, so in powder rolling, a metal powder is introduced between the rolls and compacted into a green strip, which is subsequently sintered and subjected to further hot work. Okay, so this is also one more process that in there you have to send some metal powders, okay, between the two rolls and compact it into a green strip. So you can also prepare some strip there. Okay, and that strip again you have to go for the hot working, cold working, and also you have to go for the heat treatment or the annealing cycle. Then again you have to increase the temperature because you have to, because now whenever you are rolling, so probably the strength will be not so high. Okay, so then you have to go for the annealing. The moment you have to go for the annealing, then all the parameter you have to take care. Whatever we have studied, the heating rate, the cooling time, and the cooling time. That three things you have to understand. A major advantage of powder rolling is the elimination of the initial hot ingot breakdown step. Okay, and which corresponding large economy is needed for the capital economy. So you have to, because you cannot tell that whenever we are going for the powder technology or maybe the powder rolling. So if you do not think that everything is perfect there, maybe some advantage you will find there and maybe some disadvantage again you will find there. But depending upon our infrastructure, our requirement or our sample, whatever we have, let's say, this is feasible for the powder rolling, then we can go for the powder rolling. But if it is not feasible, then you cannot go. You have to go for the other process. Other advantage may be the minimization of the contamination in hot rolling and the production of seed with very fine grain size or with a minimum of reproductiveness. So one more also you have to think about the contamination. If you can decrease the contamination, this is also very good. Okay. And the production seat also the grain size, because whenever we are talking, if you will see, I gave one schematic diagram of the the rolling mill actually, that how the grain size it is affecting from the initial raw material and whether it is changing. So that means the grain particles, it was like, initially it was stretched because you are pressed, then it was like, small grain particle, it was grow. Then in the final state, the grain growth of the big particles, or maybe small particles, whatever you had created there, then that grain already growth there in the final state. That also we have shown. If you want, you can just go back to that metal working. So I have taken that the same example of the rolling. Okay, two rolls were there and the metal piece was passing. Then how the the microstructure, how it was changing there. Also that you can just have a look, maybe when you have free time, right? Is it clear? Yeah.
Yes, sir.
So now we will see. Yeah, yeah. Any question? No? Okay, fine. Okay. So now when we talked about the basic background of the rolling, then part of the classification like hot rolling and cold rolling, then part of the raw materials size and part of the product size. Now we have to understand what are the rolling mills are available. Okay, so we have several kind of rolling mills you have. So if you will see the rolling mills, this depending upon, so various rolling mills are available to deal with the variety of applications. So you cannot tell that, for example, if you have 2 high roll mill or maybe 3 high roll mill or maybe 4 high roll mill, you cannot tell that I can use, for example, if one piece of material I have, so I can go directly for the 4 high. Why we are going? Because we have to see all the parameters, for example, the energy, how much of energy is required there, what is the cost we will spend there, how much will be benefit. So everything you have to see. So which one is the cheapest for you and which one is a demand for certain application, then you can choose that kind of rolling process. The basic rolling mill consists of two opposing rolls and is referred to as two high rolling mill. Whenever we have the two rolls, normally if you will see this schematic diagram here, you have two rolls and the two rolls are opposing rolls. So that means this is rotating here in this anti-clockwise, and this bottom roll it is rotating clockwise. And the metal piece you have put it here, that means with a certain force. And these rolls, they have two things. They have two work. One is this roll will take back or maybe pull this metal piece. At the same time, it will squeeze also. Two things what we have studied. And the rolls in these mills have a diameter in the range of 0.6 to 1.4 meter. You can imagine 0.6 to 1.4 meter if you have the rolls diameter. And the two high configuration can be either a reversing and front reverse. So two things here there. The moment you have the two high roll mill, there are two ways. One is a reversing roll mill and second one is a non-reversing roll mill. When you have the reversing roll mill, so that means this metal piece you are putting here from left hand side and it is going, and again the rolls it can move again in the opposite side, again it will come back. Okay, so that it can decrease the dimension again. Whereas if you have the non-reversing, so this is only one way. So that means this is going from the one side and this is going to the other side only one. But the moment here, if you will see our Xerox, sometimes we are making, both the pages. One time it is coming out, then again it is going back, and then again it is taken. So this is known as the reversing rolling, and this one is known as the non-reversing rolling. Right? Is it clear? Yeah. Fine.
Yes, sir. Yes.
The second one, we have three high configuration. So you can see here in three high, you have three basically roles here. So one is in the upper hand side here, and this is the second one, and this is third one. So here what we are doing, so one piece, the metal piece you are putting here from the left hand side, it is going here, okay, and the moment it is going here, you can see, and this metal piece again, it is going back on the bottom. And the moment it is going back in the bottom, you can see the rotation movement of the middle row. Okay, so the moment it is going towards in this direction, and again it is going in the similar way, it is going. So the moment it is going in the similar, so this metal piece again it can pull it out in that side, right? But here this is this is only in anti-clockwise, but this is in clockwise, and the moment it is clockwise, so this metal piece, you can imagine this first metal piece, it will pull in that way. Then again when it is going back to the left hand side, again it will pull back in that direction, right? So these are three high roll mill. So you have to understand if this is you need much more accuracy there, or with the dimension. If you want to make it in three high roll mill, so you can use also this or this setup. Okay. So similarly, there are I just roll here. several alternative arrangements you have for the three high configuration that I just told, and there are few advantages are gained in reducing the roll diameter. So one more thing that if you have the roll diameter, whatever we have talked about, 0.6 to 1.4 meter, the roll diameter you are using. So now, is it possible to decrease the roll diameter? For example, if you can consider that other way, like your motorbike. So your big wheel you have and the small, like the Activa or the scooty what you are using, they have the small roll, okay, or the small wheel. So there are few advantages when you are reducing the roll diameter. Roll work contact length is reduced with a lower roll radius, and this leads to lower force, torque, and power. So that means whenever you have to think about the other parameter, but I'm talking every time. So you have to think about the forces, you have to think about the torque, and you have to think about the power. If you are decreasing, then why not you are giving to the smaller roll? So to to enhance this kind of thing or to decrease the force, torque, and power, you can probably there is a chance to decrease the roll diameter. The moment you can decrease the roll diameter, then you can go for the four high rolling. So it uses actually two smaller diameter rolls here. Okay, two smaller diameter roll and the bigger diameter roll, what we have normally used in two high roll, the roll mill or the three high roll. So owing to the high roll forces, the smaller roll would deflect elastically between their end bearings at the work pass through unless the larger packing rolls were used to support. So that means the two rolls actually you can see the direction. Okay, so this is moving in anti-clockwise and this is moving in clockwise. So similarly, this is moving in clockwise because you have to pull it back this sample. Okay, and these two rolls actually the bigger rolls they are supporting to the smaller rolls. Okay, so these are another one new technique whenever you are talking about the instead of the two high mill or three high mill, you are going for the four high mill, right? Yeah, right.
Yes, sir.
So then you can another some two, three new things are there. Then apart from this two high, three high, and four high, and now probably you cannot find some in some other books also. I just collected this one. So in one book you cannot find all the detail. So another role configuration that allows the smaller working roles against the work is the cluster rolling. Okay, so this is known as the cluster rolling. So you can see here you have a small roll here, then two supporting rolls are here on the above and also on the bottom, two supporting rolls are here. Okay, but they have taken the smaller rolls here because as they follow the similar way what we have discussed in the four high rolls. Then one more thing is the Sensimir mill is a modification of the cluster milling rod. This is the modification of the cluster rolling rod in which there is very well adapted rolling thin flexible foil from high strength alloy. So if you have, because this depends upon your application and also this depends upon your material, what kind of material you are putting. If you have some high strength alloy and you are producing some thin sheets of foil directly from there, so you can go for the Sensimir. Okay, so that is the advanced version or the modification of the cluster rolling. And to achieve higher throughput rates in standard products, a tandem rolling mill is often used. Okay, so if you see here, this is the tandem rolling mill. So you have what you have. So you have the continuous things are there, like continuous rolling are there. So if you want to do directly, like in the similar shape, because instead of going to a high mill, then again you have to go for another mill. So two or three times if you will go. Instead of that, if you want to go for tandem rolling mill, because here three continuous sets are for one setup or one process. So that means if you want to decrease, in that one process only, so you can follow the tandem rolling. So what will you can see here? So the thickness, initial thickness is let's say here T you have, but you are decreasing the thickness here. So apart from this also, whenever you are going to another roll, then again you will find the surface finish, then also again a little decrease here. So you will find the final set. You do not think that only three set are there. Maybe if you want, maybe more also, they have you have to arrange in that way. Maybe two also you can make it, or three, or maybe four or five also you can make it. And also one more instead of that, because here only two rolls are there. But if you want to make it in a continuous four stand mill also, all the four stand whatever we have discussed earlier, if you want to make also in a in a continuous stand or maybe together or in a series, then also you can put. So you can maybe clearly you can define here the thickness how it is decreasing from here. One, initial thickness is this one. Then again you can decrease. Then again you will decrease. Then again, then finally you will find here. And again you can make a roll here, or maybe you can cut. Okay, so these are different kind of a new technology you have, so that you can make it in one step. You do not need to go for another two or three steps. Okay, you can make it in one step. Fine. Yeah. Okay. So one more slide I think I have. Is it clear? Okay. So one more thing, this last slide I have, if you have the planetary mill. Okay, so this is like planetary mill. So different rolling mill design is the planetary mill, and this consists of pair of heavy packing rolls surrounded by a large number of small planetary rolls. So you can see them. Okay, so there is a big roll here. Okay, and in this big roll, one we are calling this a packing roll. So here small planetary rolls are there. Okay, so what you are doing here, you are getting, if you have a metal piece here, you are finding like very small thin or maybe the like strips you are getting from. So these are also new kind of we are calling this is planetary mill. So you can just have a look whatever I just wrote there, whatever I explained maybe in the like in the text format I just wrote. Then one more, the last one, the pendulum mill uses a two small diameter work rolls which reciprocate over the arc of contact hold reduce a slab to a thin sheet. And the contact bend strips a rolling process using 4 high mill with a smaller diameter floating bend. Okay, so this is also one kind of like mill. I could not find the photo. Maybe I will try to put some like schematic diagram from the pendulum mill so that also you can understand. Okay, this is like a too small a diameter workload you have. Okay, so these are also like what kind of we have already discussed. We have already discussed 2 high mill, 3 high, then 4 high, and then cluster, then planetary, then the continuous, the series, then also the pendulum. Okay, so these are in the book. Actually, you will find 2, 3, and 4. But some like in some book you are finding this kind of advanced stage also. You can just have a look. Okay. Yeah. Fine. Okay. Any question?